Hello and welcome, students. I hope everybody is doing well. So, this is me, and I welcome in this session. This is lecture number 5th of chemical reaction and equation. So, let's begin this class without wasting our time. So, guys, here we are. So, in this session, we will study about oxidation and reduction reactions. This is another very important type of reaction. Okay, so first of all, I will teach you what is oxidation. So, addition of oxygen or non-metallic element or removal of hydrogen or metallic element from a compound is known as oxidation. So, I hope that you might be confused at this point that what did I say. So guys, you do not need to be confused because I will explain each and every point what I have said. So basically guys, what happens? So basically guys, oxidation is nothing but addition of oxygen in a compound or in an element. Okay, let's suppose, let me give you an example. This is copper. It is in its solid state. When this copper reacts with oxygen, then what will happen? It will make copper oxide. It will make copper oxide. Let me write its name, copper oxide. Okay, so how did it happen? Basically, here you can see it is very clear that copper is oxidizing into copper oxide because oxygen is added into this copper. So we will say that copper is oxidized into copper oxide. I hope guys this point is clear to you. Now let's talk about the second point. So let's suppose guys this is a compound hydrogen sulfide. Okay, this is hydrogen sulfide. Now, what happens when this hydrogen sulfide react with oxygen? Then it will give you sulfur plus water. Okay, this is what? This is sulfur, and this is what? This is oxygen, and this is hydrogen sulfide. Let me write it here. Hydrogen, hydrogen sulfide. So you can see that hydrogen is removed from sulfur. Okay, this is sulfur, and here on the reactant side, previously it was making a compound with hydrogen, but after it reacts with oxygen, it becomes sulfur and hydrogen is removed. So we will say that this hydrogen sulfide is oxidized into the sulfur. So oxygen is, or you can say oxidation is not only the addition of oxygen, but it is also the removal of hydrogen. Okay, mind my words what I'm saying. I'm saying that addition of oxygen is oxidation and removal of hydrogen is also oxidation. Okay, I hope guys this thing is clear to you. Now guys, let's see the another example to understand this oxidation reaction. Let's suppose this is hydrogen. This is a molecule of hydrogen. And when this reacts with Cl2, which is chlorine gas, this is chlorine gas and this is hydrogen gas. So when these two molecules reacts, then they will give us 2HCl, that is hydrogen chloride. That is what? Hydrogen chloride. Let me write it here. Hydrogen chloride. So you can see in hydrogen, this chlorine is added in the product. This is in reactant side, and when they form or when they combine and they make hydrogen chloride. And this Cl2 is a non-metallic element. So you can see that there is an addition of non-metallic element. So that's why it will also called oxidation reaction. Okay. So these are the three examples of oxidation reaction. I hope guys these examples are clear. Okay. One thing you should remember that the chemical reaction should always be balanced. Okay, if it is not balanced, then you have to balance it. So let's check this chemical reaction, is it balanced or not? So there are two elements of hydrogen on the reactant side, and on the product side also there is two hydrogens. Okay, but you can see that oxygen on the reactant side is 2, but here oxygen on the product side is 1. So that's why this is not a balanced equation. So you have to balance it. How can we do it? I have already told you in the previous slides or in the previous lectures that how do we balance a chemical equation. So here what we can do, we can simply multiply with 2, and here also we will simply multiply with 2 like this. Okay, and here also I will multiply with 2. Okay, so you can see here the number of hydrogen on the reactant side is 4, and number of hydrogen on the product side is also 4. Okay, number of oxygen on the reactant side is 2, and number of oxygen on product side is also 2, and number of sulfur element on the reactant side is 2, and on the product side as well it is 2. So that's why it is become a balanced chemical reaction. But here this reaction is also not balanced. So it is also needed to be balanced. So how can we do it? Here you can see copper is 1, but here copper is also 1. Okay, that's okay, copper is balanced. But oxygen on the reactant side is 2, but on the product side it is only 1. So that's why it is an unbalanced equation. So you have to again balance it. How can we do it? I will simply multiply here with 2. Okay. But now what happened guys? I multiply here with 2, then number of oxygens becomes 2, and oxygen is balanced now. But you can see that number of copper also becomes 2. But here copper is present only 1, or you can say only 1 copper is present. So what can we do to balance this copper? I will again multiply with 2 here. Okay, and now you can see guys the number of copper and oxygen is balanced. So I hope guys you might have been able to understand what is oxidation. So you have to remember these 3 points. Then addition of oxygen is oxidation, removal of hydrogen is oxidation, and addition of a non-metallic element is also oxidation. Now, after understanding this oxidation clearly, let's move on to the next slide and let's talk about what is there for us. Okay, guys, so here we are. Here, in oxidation and reduction reactions, we will study reduction. Okay, what we will study? We will study what is reduction. So basically, guys, reduction is nothing, but you can say that it is just opposite of oxidation. It is opposite of oxidation. Now, how can it be opposite of oxidation? So, you can understand this by the definition, and after reading this definition, we will talk about some examples as well so that you will clearly understand. So, guys, addition of hydrogen is reduction. But when we were discussing, remember when we were discussing oxidation here, so what is written? Addition of oxygen. But here what is written? Addition of hydrogen. So it is just opposite. That addition of hydrogen is reduction. Now, addition of metallic element. Addition of metallic element is what? It is also reduction. Here you can see that addition of non-metallic element is oxidation. But if you change this non-metallic element with metallic element, or you can say that if a metallic element is added, so you will say there is a reduction. Now, removal of oxygen is what? Reduction. And removal of non-metallic element is also reduction. So in oxidation, what happens? Addition of oxygen or non-metallic element is oxidation. Okay, but here addition of hydrogen or metallic element is reduction. Here what you can see that removal of hydrogen or metallic element is oxidation, but here removal of oxygen or non-metallic element is reduction. Okay, so if you understand oxidation, then you will automatically be able to understand reduction. Okay, now guys, let's talk about the examples of reduction reaction.
So guys, what is the example in this case? Let's take an example of potassium chlorate. So what is potassium chlorate? KClO3. This is potassium chlorate. Now this will break into potassium chloride and oxygen. And guys, here you can see the oxygen is removed from potassium chlorate. Let me write it here. Potassium chlorate. So oxygen is removed. That's why you will say that this is an example of reduction reaction. Okay. Now guys, let me balance this reaction. If I multiply here with 2 and if I multiply here also with 2 and I will multiply here with 3. So you can see here 6 atom of hydrogen is present. Here also this 3 will be multiplied with this 2 and 3 atom of oxygen is present here. 2 atom of potassium is present on the left side and on the right side also the number of potassium atom is 2. And if I talk about this chlorine atom, then on left side and right side, the number of chlorine atom is equal. So this is a balanced equation. I hope guys this point is clear to you. Now, let me tell you another example as well. Let's suppose this sodium is reacting with hydrogen. So this will give you NaH. Here guys, what is happening? This hydrogen is getting added in sodium. So this sodium is a metal. So whenever hydrogen is added into a metallic element, then what will happen? The hydrogen gets reduced. Okay, and this sodium will get oxidized. Sodium is getting oxidized here. Sodium is getting oxidized. So I hope guys this point is clear to you that this is an example of oxidation reaction. Now guys, let's talk about the other thing as well. Let me give you another example. Let's suppose the carbon which is in solid state and this is reacting with oxygen which is in gaseous state and it is forming carbon dioxide, and here you can see that oxygen is added into the carbon. So that's why the carbon is getting oxidized. I hope guys this point is clear to you. So let me balance this reaction as well. You can see here the number of hydrogen is 2, and here on the right side the number of hydrogen is only 1. So that's why this is not balanced. So to balance this, let me multiply here with 2. So if I multiply here with 2, now guys you can see that this reaction is completely balanced. Now these are the example of oxidation and reduction reaction. I hope guys these points are clear to you. If these points are clear, so let's move on to the next slide.
Here we will talk about oxidizing and reducing agent. What is oxidizing and reducing agent? So it is basically very simple. So I will give you an example to understand this. Let's suppose the carbon is reacting with oxygen and the product is carbon dioxide. So in the oxidation reaction we have seen that we will say carbon is getting oxidized into carbon dioxide. So this carbon is basically the reducing agent. It is what? Reducing agent. Okay, because it is getting oxidized, and the substance which gets oxidized is known as reducing agent. Okay, now guys, let me give you another example. So let's suppose, let me write here another reaction. Let's suppose if zinc oxide, this is what? This is zinc oxide. If this zinc oxide reacts with carbon, and this carbon, you can say, it will become zinc plus CO, which is carbon monoxide. Carbon monoxide. Now guys, what will happen? You can see that this zinc oxide is getting reduced in zinc because there is a removal of oxygen. So we would say that this compound, this zinc oxide, is getting reduced into the zinc. So the compound or the element or the substance which is getting reduced, we will call it oxidizing agent. Let me write it here. Oxidizing agent. Okay, I hope this thing is clear. Which is getting reduced, we will call it oxidizing agent, and which is getting oxidized, we will call it reducing agent. Okay, if I am writing it here, oxidation, here carbon is oxidized, so that's why it is acting as a reducing agent, and here in the second equation the zinc oxide is getting reduced. Let me write it here, reduced, that's why it is oxidizing agent. This is basically very important. Okay, and guys, you should also remember one thing, that whenever oxidation happens, then reduction also happens simultaneously. Okay, whenever you can say whenever oxidation occurs, then reduction also occurs. Okay, these two reaction always occur simultaneously. Okay, I hope this thing is clear to you. So now guys, let's move ahead. So here we are guys. Here we will talk about the redox reactions. Okay, we will talk about redox reaction. What is actually a redox reaction? So let's see. So guys, redox reactions are the reactions where oxidation and reduction happens in the same reaction. Okay, or you can say redox reactions are the reaction where oxidation and reduction both take place simultaneously. Okay, so let's suppose here example is also given. This is copper oxide. This is what copper oxide, and this copper oxide is reacting with hydrogen. This is what hydrogen, and you can see that two things are happening here. There is an removal of oxygen, and what is we call removal of oxygen? We will call it reduction. We will call it what? Reduction. And you can also see that there is an addition of oxygen, and oxygen is added into the hydrogen. So that's why we will also say that hydrogen, or you can say hydrogen is getting oxidized because oxygen is being added into the hydrogen. So that's why there is an oxidation as well. I hope guys this thing is clear to you. Now we just wanted to see that these two things are happening simultaneously. Reduction is also happening and oxidation is also happening in the same reaction. So these type of reactions are known as redox reactions. Okay, that is the reason when we were studying oxidation and reduction, so I was telling you that we have to be very clear at this point, because when we study redox reaction, then we need to be very clear with oxidation and reduction. So guys, you can see what are redox reactions. These reactions are the reactions where reduction and oxidation takes places simultaneously. Okay, now guys, after understanding this example, let me tell you other example as well.
So example here is, let's suppose the hydrogen, which is a gas, it is reacting with oxygen and it is forming the molecule of water. Okay, now if you want to balance this, then how can we balance it? Let me multiply here with 2. So you can see on left and both and right, on both sides, the number of oxygen atoms are equal. But here the number of hydrogen atoms are not equal. On right side, here the number of hydrogen is 4, but on the left side only 2 hydrogen atom is present. So to balance this, let me multiply here with 2. Now this reaction is balanced. So guys, here you can see that oxygen is adding to this hydrogen. So that's why this hydrogen is getting oxidized. But this hydrogen is adding to this oxygen. So that's why this oxygen is getting reduced. So guys, here hydrogen is getting oxidized and oxygen is getting reduced. That's why this is an example of redox reaction. Okay, I hope guys this point is clear to you. Now guys, this is basically what? This is, so that is what? That is dihydrogen monoxide. We can also write it here, dihydrogen monoxide, because you can see that two atoms of hydrogen is present. That's why I'm using this di, and only one atom of oxygen is present. That's why I'm using mono here. So I hope guys this thing is clear to you. If it is clear, so let's move on to the next slide.
Okay, students, so here we are. Here we will see some of the examples so that this thing will clear more. So here we have to identify the reducing and oxidizing agent in the following reaction. So when I taught you reducing and oxidizing agent, then I told you that the compound or the element which gets reduced is oxidizing agent, or the compound or the element which basically oxidize will be known as reducing agent. Okay, so let's solve this first question. Okay, here we will check that which is getting oxidized or reduced. So you can see that this is zinc oxide. This ZNO is what? Zinc oxide. Okay, now this zinc oxide has become zinc, means there is a removal of oxygen. So guys, we know that removal of oxygen is known as reduction. It is what? Reduction. And because there is a reduction, so we will say that ZNO means zinc oxide is our oxidizing agent. Okay, oxidizing agent. Now guys, let's talk about this carbon. So you can see there is an addition of oxygen in carbon. Okay, there is an addition of oxygen in carbon. So this is what you can say, this carbon is getting oxidized into the carbon monoxide. This CO is what? This is carbon monoxide. So this is getting oxidized. So that's why this carbon is reacting as a reducing agent. Reducing agent. Okay. I hope guys this thing is clear to you. So the solution of this first question is oxidizing agent is ZNO. Oxidizing agent is ZNO. And second, reducing agent is what? This is carbon. Okay. Now guys, let's talk about the second question. Here we have given this equation. Okay, we have given this equation and we have to find out that which is getting oxidized and which is getting reduced, so that we can identify the oxidizing and reducing agent. Okay, MnO2 is basically manganese dioxide. Okay, MnO2 is what? Manganese dioxide. Okay, now guys, what happens when this react with HCl, which is an acid, or we will call it hydrogen chloride. Okay, when this manganese dioxide reacts with hydrogen chloride, then it will give MnCl2, which is manganese dichloride, and this is what? This is water, and this is chlorine. Now guys, we have to find out that which is getting reduced. So you can see that this manganese dioxide is converted into this MnCl2. Okay, so there is a removal of oxygen. So because there is a removal of oxygen, so we will say that reduction is taking place. And because reduction is taking place, that's why this MnO2, you will say this is acting as oxidizing agent. So oxidizing agent. Okay. And why this is an oxidizing agent? Because here it is getting reduced into MnCl2. Okay. Now guys, let's talk about this hydrogen. So you can see that there is an addition of oxygen in this hydrogen. You can see this hydrogen, the hydrogen chloride is getting converted into this water molecule, or you will say hydrogen dioxide. So there is an addition of oxygen. That's why we will say that oxidation is taking place here. Oxidation, let me write it clear for you. Okay, so basically guys, oxidation is taking place here. So that's why this HCl is an reducing agent. Reducing agent, because it is getting oxidized into the H2O. So I hope guys, this question you might have been able to understand the solution of this question. So here this MnO2 is what? This MnO2 is oxidizing agent and this HCl is reducing agent. And we also understand then what is reducing agent and what is oxidizing agent. Now guys, let's talk about the second question, that when magnesium ribbon burns with a dazzling flame in air and changes into a white substance, magnesium dioxide or magnesium oxide, is magnesium being oxidized or reduced in this reaction? So basically in this question, we have been given a reaction and we are asked that we have to find out whether magnesium is being oxidized or reduced. So first of all, we have to know, or we should know, how to write a chemical equation. So magnesium, which is in solid state because we are burning its ribbon, and this is reacting with oxygen. Okay, whenever we burn something, so what do? We basically making it react with oxygen. Okay, now guys, this will become magnesium oxide. Okay, now we have to balance this equation because this is not balanced yet. So this is a balanced equation. Now guys, you can clearly see that this magnesium is converted into the magnesium oxide. So we will say that this magnesium is basically oxidizing into the magnesium oxide. So this is our question, that is magnesium being oxidized or reduced. So magnesium is being oxidized. So the answer of this question is magnesium is being oxidized. I hope guys this thing is clear to you. Now guys, let's move ahead and let's talk about the other things. Okay guys, so here we are. Here we have been given a question. So this is a chemical reaction. This is what? A chemical reaction where PbO, which is lead oxide, and it is reacting with carbon and it is converting in lead and carbon dioxide. So we have been given some options. So first of all, we will read the options, and before reading the option, let me write the name. So this is lead oxide, okay, and this is carbon, this is lead, and this is carbon dioxide. We already know it. So guys, what is happening? You can clearly see that this lead oxide is converted in lead. So that's why this lead oxide is reduced in lead. Now guys, let's talk about this second reactant, that is carbon, and this carbon is converted into this carbon dioxide. So we will say that carbon is oxidized. Okay, it is getting oxidized into the carbon dioxide. Now let's read this first option. So lead is getting reduced. So basically guys, you can see that lead is not getting reduced. Lead oxide is getting reduced. So that's why this is wrong option. Now carbon dioxide is getting oxidized. So you can see that carbon dioxide is not getting oxidized. It is carbon which is getting oxidized. So this is also wrong option. Now let's talk about this option number C. Carbon is getting oxidized. It is true. Of course, carbon is getting oxidized. Lead oxide is getting reduced. It is also true that lead oxide is getting reduced into the lead. Now guys, we have been asked the incorrect option. So you know that incorrect options are A and B. So you can see that in first option, A and B are given. So this is our right answer. Okay, so basically these two are incorrect statements. Now let's move ahead and let's talk about the other question. Okay guys, so here we are. Here we have given a situation, or we have given a chemical reaction. So let's read this question. What happens when dilute hydrochloric acid is added to iron filling? So basically guys, we have to know what is hydrochloric acid. So we all know that hydrochloric acid is HCl. Okay, and when we add iron fillings, so basically when we add iron fillings in the solution of this hydrochloric acid, so we are actually reacting this hydrochloric acid with iron filling. So iron is represented as Fe. Okay, it is written as Fe. It is its symbol. So when this these two reactants will react, then they will give us FeCl2 plus H2. FeCl2 plus H2. Now guys, this reaction is not balanced. So we have to balance it. So I will add it 2 here, and now it has become balanced. Okay. So guys, why this reaction took place? Because we know that Fe is highly reactive than hydrogen. It is more reactive than hydrogen. So it will displace this hydrogen and it will take its place. So this is the reaction. Now here let's read this option A. Hydrogen gas and iron chloride are produced. So it is basically true. This is iron chloride, iron chloride, iron chloride, and hydrogen gas is produced. So that's why this option is true. Okay guys, I hope you understand this. And these options are wrong because here chlorine gas and iron hydroxide, so this is wrong. No reaction takes place, this is also wrong. Iron salt and water are produced, this is also wrong. So this is right option. Now let's move ahead. So here we have been given an equation and we have to balance it. Okay, write the balanced chemical equation for the following reactions. So first of all, I will write this equation, calcium hydroxide. So what is calcium hydroxide? CaOH all twice. This is calcium hydroxide. and you should remember these chemical formulas of the compound. Okay. Now let's talk about the second reactant, carbon dioxide, CO2. This is carbon dioxide. Okay. And when they both react, then they will give us CaCO3, which is calcium carbonate plus water, H2O. Okay. Now guys, we have to balance this chemical equation. To balance this chemical equation, first of all, we have to write down, or we have to check whether this reaction is actually unbalanced or not. So this is calcium, this is oxygen, this is hydrogen, and this is carbon. Now guys, this is LHS side and this is RHS side. Now guys, you can see that on the reactant side, there is one element of calcium, and on the RHS side, there is also one element of calcium. On the LHS side, there are four elements of the oxygen, and on the reactant side, there is also four elements of RHS or oxygen, and on the reactant side, hydrogen elements are 2, and on the RHS side it is also 2. And if I talk about carbon, then it is also 1 on reactant side, and on RHS it is again 1. So you can see guys, all the elements are equal on both sides. So that means this equation is already a balanced equation. So we do not need to further balance it. So I hope guys you might have been able to understand all the solutions. So thank you so much. Now I am ending this lecture. So bye bye guys.